Hello, guys. We are talking about a really exciting topic, units. So, the metric system is used in scientific measurements and it was developed in France in the late 18th century. In the United States, we traditionally use the English system. However, in our everyday lives, we can also see the metric system unit. So, for example, if you take a can of soda, you can see that the volume is also given in milliliters in this case. I hope you guys can see it. So, we are actually using both types of units, and units are actually completely arbitrary. They are just made up, but they are extremely important in our everyday lives. So let's take a look at an example. So there was a Mars climate orbiter which was built at a total cost of over $300 million, and in September of 1999, after almost 10 months of traveling to Mars, it just burned and broke into pieces. What happened? So, actually, the software calculated the force of thrusters needed to exert in pounds per force. And the separate piece of software took the data, assuming that it was in metric units, newtons. It was a pretty big deal just mixing up units. So, if you will work at NASA or any other place, make sure that you have your units right. So, actually, what's really interesting about units is that based on the international system of units, we only have seven base units, okay? Seven base units, and you can derive all other units based on those, okay? These are also called SI units. Now, the seven base units are meter, kilogram, Kelvin, second, mole, ampere, and candela. And some of the derived units are volume that we use pretty frequently in our everyday lives. It's derived from length. So centimeter cubed, 1 centimeter cubed is actually 1 milliliter, okay? And for example, energy can be derived from the mass and velocity. So mass has the units of kilograms, and then velocity squared is meter per second squared. It's gonna give us joules. You are going to see joules pretty often in chemistry classes and also kilojoules. All right. So let's dive a little bit deeper into units. Let's talk about prefixes. So prefixes are used to convert a so-called base unit into units that are more appropriate for our common usage. For example, if I want to measure the length of my phone, right? What is the length of my phone? I'm not going to try to measure it in miles, right? That wouldn't make any sense. Similarly, I'm not going to measure it in kilometers. I will probably give the number in centimeters or millimeters. So to find the appropriate number and the appropriate unit, we have to use these different prefixes, okay? So here we can see the conversion factors, the name of the prefix, and the symbol for it. So let's try to understand how this table works. Let's try to find the name of the units that equal to the following that is given to us. So what is the name of the unit that is 10 to the third gram? So let's look at the factors and try to find where is 10 to the third. Did you find it? So 10 to the third is right here. And the prefix here is kilo. So this means that 10 to the third grams equals to 1 kilogram. Okay, so if you are not familiar with scientific notation or the meaning of 10 to the third or need a little bit of refresher, let's talk about it. So 10 to the third actually means 1 times 10 to the third. And the exponent 3 just tells us by how much do I need to move the decimal place. We don't see the decimal place right here, but it's actually right there, right after the 1, right? So if the exponent is a positive number, I have to add the zeros and move the decimal place to this direction to get a larger number. So since it's 10 to the third and I have a 1, I would have my decimal point here, and I have to move by 3 places. 1, 2, 3. See that I'm not adding any numbers, because basically what I will add simply are just zeros, okay? So 10 to the third is just 1,000. All right. Let's try to find the name of the unit that is 10 to the negative 9th second. Where is 10 to the negative 9th? Did you find it in the table? It is right here. So the name of the prefix is nano. So we are going to have nanoseconds. So 10 to the 9th, negative 9th second is actually 1 nanosecond. Okay? So how can we understand 10 to the negative 9th? Similarly, the 1 times 10 to the negative third, here we are going to assume that it is 1 times 10 to the negative 9th. However, because the exponent is a negative number, we will have to move the decimal place to the other direction, okay? So we will have to move the decimal place to that direction. So let's say I have my 1, right? Because 10 to the negative 9th is just 1 times 10 to the negative 9th. But I assume that I had my decimal place here, and then I have to move it by 9 to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there is my decimal place. And now I just simply fill those empty spots up with zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0. Now you can see how useful scientific notation is, because when you are doing a calculation, you definitely don't want to punch this number into your calculator, right? It would be really tedious. Okay, so I hope the units and the prefixes and how to find their names make sense. Let's take a look at a different question, and let's try to find how many micrometers are there in 1 kilometer. Well, the first question is, what is the base unit? So the base unit is going to be meters. And we are looking for micrometers in 1 kilometer. So 1 kilometers equals to how many micrometers? Okay, so let's try to find both kilo and micro in the table. Let's look for kilo first. Where is it? Did you find it? So kilo is right here, and we know the factor. Did you find micro? So micro is right here, and 10 to the negative 6th is the factor. Now I know that I can write out the following. 1 kilometer equals to 10 to the third meters, right? So that's just what the conversion factor is for, or the factor in the table. I also can say that 1 micrometer equals to 10 to the negative 6 meters. Okay, so this is all coming from this table here. And we are going to do a little bit of dimensional analysis. Let's say introduction to dimensional analysis. So when I'm converting from kilometers to micrometers, my base units are meters. Okay, So because I know how many meters are in 1 kilometer and how many micrometers are in, or how many meters are in one micrometer, I can go from kilometers to meters and from meters to micrometers. Okay, so how do I do that? I have to write out so-called conversion factors. And the conversion factors are coming from these expressions. So for example, for the first one, kilometer to meters, my conversion factor can look like this. 1 kilometer divided by 10 to the third meter. Or 10 to the third meter divided by 1 kilometer. Now, how do I know which one to use? Well, I will have to start with kilometers and I have to cancel the kilometers out. So I'm starting with km and I have to cancel it out. Now, when I have 1 kilometer, right, it's not divided by any other number. I'm going to assume that this is on top of a fraction. Okay, so this is going to be a numerator. So in order to cancel the units out on the numerator, I have to multiply it by a fraction that has the same units in the denominator. So I have to put the kilometers down here. Okay, so which one of these should I use? This one, number 1, or number 2? I'm gonna call it for number 2 because that has the kilometers on the bottom. So I know that 1 kilometer is 10 to the third meter. Okay, so if I do this calculation, I will cancel out the kilometers and have meters as my unit. Okay, but meters, I'm not looking for meters, I'm actually looking for nano or micrometers, right? So, because I'm looking for micrometers, I still have to cancel the meters out. So when I'm using my next fraction from this expression right here, how should I set up my fraction? Will the meters go on the bottom or on the top? They will go in the bottom because I have to cancel out the meters, right, to get the micrometers. And I know that 1 micrometer, right, is from here, is 10 to the negative 6 meter. All right, you can just simply punch this into your calculator and do the calculation. And what you are going to see is that 1 kilometer equals to 10 to the 9th meter. So there is actually an easier way to do this calculation, and let me show you how. So you went from kilometers to meters, right? We have an exponent of 10 to the third, and then we went from meters to micrometers where we have an exponent of the negative 6, right? So in this case, I know since I have to divide 10 to the third by 10 to the negative 6th, I am just going to subtract from each other the two exponents. So 3 minus 6 is going to give me 9. And this is the number that I'm going to use as my exponent right there. Oops, and I forgot about the micro. Okay, I hope this makes sense. So simply when you are going from kilo to micrometers, you will have to take the exponent in kilo minus the exponent in micro, and you are going to get the answer. Okay, let's do another example. So here we are asked that how many centimeters are in 32.5 nanometers. So what is our base unit here? Base units are meters. Let's try to find the centi and the nano in our table. So where is the centi? Centi is 10 to the negative 2. Where is nano? So nano is 10 to the negative 9. Okay, so again, the question is 32.5 nanometers equals how many centimeters? And we can do it in two different ways, okay, this calculation. I'm going to show you both. Well, first of all, I can use conversion factors to do so-called dimensional analysis by starting with nanometers and canceling the nanometers out using a conversion factor. Now, because I'm canceling out the nanometers, I have to have the same unit on the bottom in my fraction, right? And meters are the base units, so I'm going to put the meters up here. Okay, so what does this mean? So I'm going from nanometers to meters. From here, I know that 1 nanometer equals 10 to the negative 9th meter. And I can just simply plug in these numbers here. So 1 nanometer is 10 to the negative 9th meter. Okay, so now I arrive to meters because those are my base units, but I have to get to centimeters. So nanometers canceled out. Now I have to cancel out the meters, and the meters are gonna go on the bottom and centimeters on the top. And I can again write out the conversion factors using my table. So I know that 1 centimeter is 10 to the negative 2nd meter. Okay, so now my meters canceled out and my final unit is going to be centimeters. So if you do this calculation, you are going to get 32.5 times 10 to the, so 10 to the 9th minus 10 to the 2nd is going to be the minus 7th, and my correct units are centimeters. Okay, so you can do two things. You can punch this into your calculator, or just simply take a look at 10 to the 9th minus 10 to the 2nd, so minus 9 minus minus 2 is going to give me minus 7. Okay, let me write it out. Minus 9 minus minus 2 is going to give me minus 7. And that is just what I'm going to use as my exponent right there. Okay, now this might be a little bit trickier, but because we are using scientific notation, we would like to have only one digit before the decimal place. So we can rewrite this 32.5 times 10 to the negative 7th centimeter as 3.25 times 10. I moved my decimal place here, right? So that's gonna be 10 to the negative 6th centimeters. Okay, I hope this makes sense and see you in the next video.